and then I'll explain what that swelling is in a second. In the dorsal root, this swelling is called a ganglia. And again, you may not have studied this yet in lecture, but a ganglia is a cluster of cell bodies in the peripheral nervous system. So let's kind of pretend for a minute, this room 109, we all live in this room and we're all a cell body. So since we're part of a nerve, we're in the peripheral nervous system, this room would be called a ganglia. If I took this same room and I put us in the brain, instead of calling the room a ganglia, they would call us a nucleus. So they have different terms. As you go on in your studies, you'll see there's ganglia in the peripheral nervous system, but there are nuclei or a nucleus in the central nervous system. But both of them are the same definition, it's just two different places. So watch this. I'm going to draw a nerve in now. I'm going to do this in green to show you it's kind of an afferent nerve. I typically do my afferents as green. In the nerve, there are axons like this that go into the spinal cord, like that. So the afferent information goes into the dorsal horn. But remember before I showed you where the nuclei live for the ventral horn neurons and the lateral horn neurons? I never showed you where the nucleus lives for the afferent. I'm going to show you now. Watch this. In this ganglia, this right here is the cell body for this neuron. So notice this neuron doesn't look like a typical neuron that we've seen. Did you guys do classification of neurons yet? Unipolar, bipolar, multipolar? No? All right. So when you get there, if she gets to it this week, this is actually called a unipolar neuron. It looks different. It has all the parts, but it don't look like this. Instead of having the dendrites come off the cell body, the dendrites, look what they're going to be. And you don't have to draw this if you don't want to. I'm going to get into this a little bit later. The dendrites are down over here at the end of the axon. So the dendrites, instead of being on the cell body, they're at the end of the axon. So they're out of place. Here's the axon. It bypasses the cell body, and then the axon terminals end up right over here, or the telodendria end up right over inside the spinal cord. So let me show you where you find these neurons, guys. Let's pretend for a minute. I'm going to say this is the skin. The dendrites of these unipolar neurons are all in your skin. So if I took a needle and I stuck your skin anywhere on your body or on me, right? If I took a needle and I stuck it anywhere, watch what happens. The needle pokes the skin, it stimulates the dendrites. The dendrites send the signal, or the nerve signal, towards the spinal cord, right, which is afferent. The signal bypasses the cell body, doesn't even have to go there, and it goes right into the spinal cord. So this is the way our afferent neurons look. They look different than what I taught you back when we did this. Right? Not all neurons are the same. In the special senses, there's something called bipolar. They look a little bit different than this also. So it's important to know that they're not all the same, and this is one variation. So here we go. The reason they call this swelling, or the reason the swelling is there, is because this is where all the cell bodies live. So the area has to be a little bit swollen. So you're going to call this, let's label it DNRG. Dorsal nerve root ganglion. Again, a ganglion is a cluster of cell bodies in the peripheral nervous system. Okay, so in that, I'm drawing one, but there, there's thousands of them in here, maybe even more. There's thousands and thousands of cell bodies in here of these afferent neurons. Right? And that's why that swelling is there. Again, there's no swelling in the ventral horn because the neuron, let's put that neuron in here just to show you. The cell body lives in the spinal cord right there in the ventral horn. So watch this. Now motor signals go out this way. Right, so let's say I stuck you real hard with the knee. Oh no, how about this? Let's say after class today, before you go home to study all your anatomy, you say, you know, I'm going to have a nice hot chocolate, calm myself down a little bit. You put some water on the stove, put the pot on, right? The water on the stove and the heat on, that type of thing. And then you get a phone call. So you're talking about, you're talking about anatomy and all that stuff. And what else would you talk about on the phone, right? And then you go to grab the pot, not realizing that water's boiling and it's hot, and you grab this hot pot. So these dendrites in your hand would pick up the heat, send a signal into the spinal cord. Spinal cord, if you remember from last week, I said always integrates and processes information. It will send a motor signal back out to the muscles, say the muscles in your hand to do what, or your arm to pull away. Right? And we've all done that before. You touch something hot, what do? You don't even have to think about it. You just kind of just jerk away. So watch this. These efferent neurons here are going to your muscles. Right? And this is kind of a reflex, and I'll talk about that in a second. So that's why it's important these dendrites are in your skin. And then again, the motor neuron is going to come out this way. Right? So it's definitely always in the back of the cord. Information comes out the front. All right, and that's what we call the spinal nerve. So now, guys, here's the IVF. Here's the spinal nerve that we would see over here. So all these yellows that we're looking at right here, all this yellow stuff is from this point on. This here is all happening inside the vertebral canal. All this. So you're going to find the ventral root, the dorsal root, and the dorsal nerve root ganglion, all that on the inside. You can't see that from the outside. All we're seeing here is this part here. And I'm going to add one more thing, and we'll have this wrapped up. Any questions on this? So if I asked you next week, what forms a spinal nerve, it's going to be the union of the ventral root and the dorsal root. The two roots come together. Any question as far as what the dorsal nerve root ganglion is? Again, if you want to write this right down, a ganglion is a cluster of cell bodies in the PNS. Right? A cluster or group of cell bodies in the PNS. Okay. Anybody else? Right? DNRG. I'll even, you know what, guys? You can even abbreviate it as that, as long as you know what the words mean. Right? Dorsal nerve root ganglion. So it's a great description. Dorsal nerve root, that's this whole thing, and then it's a ganglia, it's a swelling, that's all. Okay? The last thing I want you to add to this picture is this. I'm going to erase this for a minute. So, once the spinal nerve comes out of the IVF, it divides into branches, right? Technically, it divides into 4 branches. You guys only have to know 2 for me, right? The 2 main branches. But theoretically, if you go on in your studies, you're going to learn that there's actually 4 branches, or what we call rami. Remember from bony anatomy, a ramus is a branch. So, watch this. Once the spinal nerve comes out, right, it's beyond the IVF. We can see it like on the spinal cord. One branch does this. It's usually a smaller branch. It goes to the back of the body, like this. Kind of heads around to the back. This is going to be called the dorsal or the posterior ramus. Again, always remember, a ramus is a branch. In Latin, that's what a ramus is a branch. Right, so the posterior ramus. So watch what happens. This branch goes to the back of your body, like on the back of your trunk, and it's going to innervate the muscles and skin on the posterior trunk. Right, if I go to Alex in the back here and I touch him on the back between the shoulder blades, you feel me touching you? Right now, I'm actually stimulating the posterior rami of the spinal cord, spinal nerve, the spinal nerve, and then that's sending the signals to the spinal cord. Right? He's contracting just like you, these beautiful chairs that have no support. Right now, he's contracting his postural muscles to keep him upright, and you guys to keep you upright. So there are also efferent fibers in here going to the muscles. Right, so even though I'm not drawing the red and the green, this fiber, this nerve root, this nerve branch contains both red and green fibers. It has sensory and motor. Now watch this. The bigger branch going this way is the ramus that's not posterior. We're going to say it's an anterior or a ventral ramus. Okay, and what does ramus mean? Branch. Right? Always means a branch. So this is really, these rami of the spinal nerves are going to go to the rest of the body. They're going to go to the front. They're going to kind of do the front of your chest and the lateral part of your chest. And they're going to give rise to the nerves that go down into your arms and into your legs. So this is going to do the muscles. Let me just get a different chalk here. And I'll get out of your way in 1 second, guys. Muscles and skin of the anterior, lateral, chest, and the arms and legs. So you'll see, since they're innervating such more structures, they're going to be a bigger nerve branch. You're going to be bigger, and you'll see it on the model here. Okay. It is important, and I will ask you this next week. You can't get confused. If we say horns, because everything has posterior and anterior, ventral and dorsal. If we say horns, we're just talking about gray matter. If I say columns, we're talking about white matter, right? Even though they all have dorsal horns, ventral horns, ventral columns, dorsal columns, you can't use them interchangeably. Horns pertain to gray matter, columns to white matter. Then you have a ventral root, dorsal root. This is to the formation of the spinal cord. You can't interchange them. And then we have ventral ramus, dorsal rami. When you say rami, you assume it's the branches of the spinal nerve. So you got to keep them all clear. They're all different, and they all kind of sound the same. And the only reason I'm telling you, I've seen students do it. They mix up horns with rami. They mix up columns with roots. It's all different structures. Right? So just kind of watch that. If you got this down, though, right, you'll have no problem with the model I'm about to go over now, or any questions I ask you next week. Right, this picture is so important. Anybody, Joe?
Anterior ramus has both.
Yeah. So if we were going to, let me make this a little bit bigger, because this is also sometimes a little bit of a thing of confusion. I've had students think that the back had only the afferent fibers, and this would have efferent fibers. You can sense, right? When I touched him on the back, he had sensory and motor back here, right? So watch what would happen. This is where it gets a little bit. This would be the sensory fibers from the back. The motor fibers are also like that. Right? There would be thousands of them in there. I just drew two. Same thing here. This would contain sensory fibers and motor fibers, like that. The division is here, where the sensory fibers go to the back in the dorsal root, and the ventral fibers are just in the ventral root. That's where the division is. But the nerves themselves, they're mixed. They contain both afferent and efferent. Right? Again, I know in my class we talk about sensory nerves, motor nerves, and mixed nerves. I'm not sure if you guys are going to get to it. This would be considered a mixed nerve. It has both afferent and efferent fibers. Okay? Anybody, questions or comments? You love it? I can tell. I can tell. Ready? Come up nice and close. Let's take a look at this baby right here. If you want a video, this would be a great time to video. Alex, give me like 3 or 4 sticks. I know I'm going to drop them. Joe, thank you. Grab a chair, so sit. This way people can sit and see behind you. You sit over there. This model is probably 3 or 4 stations next week. It is an important model, so please make sure you know it. So let's take a look at what we have. This is a section of the C5 cervical vertebrae, the C5. And again, you can take nice close-up pictures after. I do want you to know the bony anatomy also. If you remember, guys, from when we did the vertebrae seems like a long time ago. This was the vertebral body, right? This is the lamina, right? Or your book actually called it the vertebral arch, but these are the lamina. Anybody remember this thing sticking out in the back? What's that? What's the things that stick out? Spinous processes, and then it had a split. What do we call that split? Begins with a B. Bifid spinous, right? So here's the spinous, bifid, right? This is the like kind of the cat ears that stick up. So these were the superior articulating processes. This right here, guys, is the transverse process. This is the transverse process. If you remember, though, in the cervical spine, the transverse process had a hole in it, which was the transverse foramen. We don't see the transverse foramen because there's a blood vessel in it. So this blood vessel here and this blood vessel here, these are the vertebral arteries. They're bringing the blood. Joe, hold this up for me like that for a second. Just kind of hold it up like that. Like that. These are the blood vessels. Remember I had showed you they go through the transverse processes up and down this way? So you can put it down again. Here we see them on cross section. So you don't see the transverse foramen because there's a blood vessel inside there. So that's all the surrounding stuff. So watch this. From last week, we said there were 3 protective coverings called the meninges. So this is what you got to do. The first meninge is this one right out over here. Put my stick right at the edge, right there. That is the dura mater, right? That's the outermost one. It is the tough protector. Now watch this. If you go back to your picture you drew last week, just sitting on the other side of the dura mater, on this side, if I put my stick up against it now, my stick is up against it, pushing up against the dura mater. That is the arachnoid mater. Okay, so the dura and the arachnoid, they sit up against one another like this. If this hand was the dura, the arachnoid would sit right up against it. They just kind of lay up against one another. Okay? So the dura is on the outside, the arachnoid is on the inside. Finally, guys, the pia mater is this one here, right on the spinal cord. If we were doing dissection, we had a cadaver here, and we took some forceps and we pulled on the pia mater, it would be stuck to the spinal cord. It's right on the spinal cord. Okay? So dura, arachnoid on the other side, and the pia. Then I said there was 3 spaces associated with the meninges. Check this out. Outside of the dura, where all this fat tissue is right here, see all that adipose tissue? That adipose tissue is in a space that we call the epidural space. All right, so that's where they do the anesthesia and things like that. So an epidural injection is going into here. Why do you think there's fat in that epidural space? What do you think the benefit of having fat there is? It's a cushion, exactly right. It's a protector. So this way your cord doesn't jostle around in there. And you'll see there's also these red things, these are blood vessels. So we got major blood vessels, nerves, and fat in the epidural space. Now, between the dura and the arachnoid, you're gonna see a line. It's kind of like a brownish or a blackish colored line. That is the potential space I was talking about last week called the subdural space. There should be nothing in there, all right? Sometimes though, remember we said when people hit their head and they bleed and they get swelling, that space where my stick is now starts to fill up. That would be the subdural space, and we call it a subdural hematoma. Remember we talked about the actress Natasha Richards, son or Richards, right? She had that type of swelling there. Below the arachnoid mater, this big space here is really important. This is the space called the subarachnoid space. This is where you find cerebrospinal fluid. All right, so if I asked you next week, what is this space? You would say, what? Subarachnoid space. What is this space? Everybody. What is this space? Subarachnoid space. What's in that space? Cerebrospinal fluid. Okay, I will ask. Okay, so those are the 3 spaces: epidural space, subdural space, subarachnoid space. Epidural space has fat and blood vessels. What does the subdural space have in it? Nothing. Subarachnoid space, one more time, what's in there? Cerebrospinal fluid. Okay, so those are your meninges. One word of caution. it hasn't happened too much lately, but years ago I had students who would mess this up all the time, so I want to point it out. Sometimes this ligament right here, I'm not teaching it to you, it happens to be called the ligamentum flavum. Gesundheit. The ligamentum flavum looks like the dura mater. So if you think this is the dura mater, you're going to be wrong. You're going to be off on everything. Don't confuse that as the dura. This is the ligament that's up against the lamina here. The dura mater starts here, just inside the epidural space. All right, so I've seen students mix that up and they just get everything wrong then because they're off one. All right, that's a ligament called the ligamentum flavum. Okay, so now we've gone through the meninges. Let's take the spinal cord and kind of match this up to our picture. So the first structure I had showed you earlier was this deep groove in the front of the spinal cord. What's that called? Anterior median fissure. Excellent. So that deep groove right there is the anterior median fissure. On the back, there's a little bit of a less of a depression there. What is that one going to be? Posterior median sulcus. Excellent, right? A sulcus is a shallow depression. Now, we go in, here's our gray matter, and then here's our white matter. So let's do the horns first. In the back, right here, this would be the dorsal horn. On the sides, the bump over here and the bump over there. Lateral horn, good. And then the front, ventral horn or anterior horn. Again, just one more time as far as function, because I'm going to ask you, what's the function of the dorsal horn? It's afferent, good. Afferent information goes in here. And then the two lateral horn and the ventral horn, those are efferents. Which one was the visceral efferent? The LH, good. The lateral horn. Which is the somatic efferent? The VH, or the ventral horn, okay? So the horns are easy. Dorsal horn, lateral horn, ventral horn. What's the whole crossbar called? Gray. GC, you got gray commissure. The gray commissure, that's the crossbar, so the left side can communicate with the right side. Within the gray commissure, there's a little hole. It's a canal. What is that one called? Central canal. What's in there? Cerebrospinal fluid, right? So what are the two places so far we could tell you or ask you that this cerebrospinal fluid? Subarachnoid space and the central canal. Okay, subarachnoid space and the central canal. You good so far? The white areas were called columns. So in the back, what's this whole white area going to be called here? It's a column. So it's going to be the posterior column or the dorsal column. In the front here, anterior column or the ventral column. And then the two on the side, what are they going to be? The lateral columns. Left lateral column here, right lateral column here. Left lateral column here, right lateral column here. Okay? So again, just to put this into perspective, the neurons that are here are going to be axons. They're running up and down the spinal cord this way, right? They're running up to the brain and down from the brain, right? As you go on in your studies, you'll learn that these are what we call tracks. And these are the tracks that are affected in diseases like MS and things like that. There's a bunch of different diseases, but MS is like one of the famous ones. Okay? Alex, go.
Just a question. Like, the way you're like specifying between like the left and right lateral columns, do you have to do the same thing for the anterior lateral column?
You technically you should. They break it down. I considered it one, but if you as you go on in your studies, especially if you're going into PT, you would call this the left anterior column. This would be the right anterior column. I just did it as one. But for me, just do it as one. As you go on in your studies, it gets more specific. It gets more specific. Okay, so we got the whole spinal cord. Everybody's good on that? Let's take a look at the formation of the spinal nerve now. So we said, if I asked you next week, the spinal nerve is formed by the union of two roots. Good, two roots. So in the back, these fibers right here, guys, let me just put the stick on it like that. This is the dorsal root, right? In the front, get my hand out of the way, right where my stick is, what root would that be? Ventral root, right? Again, you can say anterior too. If you're not comfortable with ventral, just say anterior. So the dorsal root and the ventral root. Which of the two roots have the big swelling in it? The dorsal root. So watch this, guys. If you follow the dorsal root fibers over here, follow them, look at this big swelling right here. What's that big swelling called? Beautiful. The dorsal nerve root ganglion. How can you abbreviate it? DNRG. What's in there? What part of neurons would be living in there? Cell bodies, right? Because that is a ganglia. That is a ganglia. Okay, so again, if you follow this dorsal root, look at these fibers, that's where all the axons are. Here's the dorsal nerve root ganglia right there. Okay, and you can see the two, the ventral root and the dorsal root joined together to become now out here, right? Here's where the IVF would be. So this is our spinal nerve right here. Like I said earlier, there's actually 4 branches. If you go as you go on in your studies, there's 4 branches. You only need to know 2. So watch this. This little branch that's going to head to the back over here, this is the dorsal or the posterior, what? What's a branch? Ramus. Excellent. This one here, look at the bigger one. The anterior or the ventral ramus. Okay, so here's your dorsal ramus or posterior ramus. Here's your ventral ramus. This here you can ignore. This is one of the other branches. This is called the rami communicantes. We just don't have. If I had another week, I would go over that. So we'll cut that out. Okay. I'm telling you, at least 4 stations next week. You're going to see this, maybe 5. If you master this, it's a home run. Home run. Right. The neuron, that yellow neuron over there, the white neuron. That's 3 or 4 stations also. All right, so it's very easy. So you're going to blow through this test. It's so quick. It's really pretty easy. The last thing I want to do before I look at the brain is one more model. Watch this. If you want to grab your notes, you can grab. Okay. If not, everything's written